Welcome to lecture 5.4. So what we're going to be looking at for lecture 5.4 is graphing the other functions instead of sine and cosine. Now we're going to graph the other four functions. And the other four functions are tangent, cotangent, secant, and cosecant. So if you'll recall earlier, the periods for sine and cosine were 2 pi. Now it changes when we look at tangent and cotangent, as well as secant and cosecant. So tangent and cotangent have a period of just pi, where we have some possible transformation inside for each of them. Then secant and cosecant have a period of 2 pi. So this is also similar to sine and cosine. Alright, and once again, some version of a shifting on... Now remember, these are the transformations when you plus some number to your 2 pi, or you plus some number to the pi. That's a transformation to the right or the left, or a phase shift. For example 1, we're going to graph the function y equals tangent of x. Now, one of the easiest things to remember for graphing these other functions is they're based off of sine and cosine. Okay, remember we create them kind of from sine and cosine. And if you recall, tangent is sine of x divided by cosine of x. So we're going to point out the main points that I would like to see when you're graphing these. Now, what are some of the main points? Well, first off, we're going to go ahead and figure out one of the more important things for tangent, as well as cotangent, and secant and cosecant. It's the fact that these are all fractions, if you remember. Remember, cotangent is cosine of x over sine of x. Secant is 1 over cosine of x, and cosecant is 1 over sine x. These are all fractions, which means they have the possibility of being undefined, which also means they all have asymptotes. Okay, so that's the first thing that I would suggest doing whenever you're graphing one of these, figuring out the asymptotes. Okay, so we're going to find the asymptotes. Find the asymptotes. The next thing we're going to find are the zeros, and then the 1 values. Okay, and these are how we're going to be graphing all of the tangent, cotangent, secant, and cosecant values. Those are the easiest ways that I've found for graphing them. Well, the first thing is, how do we figure out the asymptotes? Well, that would be when our function is undefined, which basically is when cosine is 0. Okay, so let me write that down. Whenever cosine of x is equal to 0, tangent will be undefined. Okay, so let's write that out. So cosine of x equal to 0, then tangent of x is undefined. Well, let's recall our unit circle. When is cosine 0? So cosine is 0. Let me write this out here. Cosine is going to be 0 at these 2 points here. And that is pi over 2 and 3 pi over 2. Okay, so let's go ahead and write those down. So those are our asymptotes. At pi over 2, that's when cosine of x is equal to 0. And then 3 pi over 2. Gotta draw my dotted line here. And once again, whenever you're asked to graph these, especially on an exam, the asymptotes are just as an important part of your graph. So make sure to write those in. Alright, so there we go. We have those. And then we'll also go ahead and include the negative asymptote. Alright, so there we have our asymptotes. Next thing we're going to figure out are our zeros. Okay, so we did the asymptotes. Check. Let's do our zeros. Well, the zeros. So, when is our function here equal to 0? Well, it's equal to 0 if we have a 0 on the top. Well, that's basically when sine is 0. So sine of x is going to be equal to 0 when? Well, when tangent of x... Sorry. Sine of x is 0, which means that tangent of x is going to equal 0. So where is sine 0? Sine is 0 at these 2 points here. At 0, pi, and as we go around again, also 2 pi. So those are our zeros. Let's go ahead and write this down. At 0 we have a cross, at pi we have a cross, and at 2 pi we have a cross. So 2 pi 0, pi 0, and 0, 0. Awesome, we found those values. Next thing we get to figure out are our 1s. Now the ones are a special case. How do you get 1 if you have a fraction? Well, you get 1 if you have the same number on the top of the fraction as the number you have on the bottom. Well, that means that's when x and y are the same number. So on our unit circle, when are x and y the same exact number? That'd be over here at pi over 4, 3 pi over 4. Here, let's see what value is that, 5 pi over 4. And lastly, at 7 pi over 4. How do we know that's when they're equal? Remember, that's when they're both the root 2 over 2 values. Okay, and they're not always going to be positive 1. They might be negative 1. If you recall, over here in 7 pi over 4, we're going to have a positive x value, but a negative y value. So that's going to give us the negative 1. So in quadrant 1, we'll get a positive 1, as well as in quadrant 3. Because in quadrant 3, x and y are both negative, which means when you divide them by each other, you're going to get a positive 1. And then in quadrants 2 and 4, we're going to have a negative 1. Let's go ahead and graph these values in. Boop, boop. Now once again, you're going to notice that I'm using values in the negative side, and that's just usual because if you recall, these are just repeating values of each other, just like we had with sine and cosine. We're just continuing to go around circular values. So the negative, basically that would be if you went down in the reverse order, like when we're finding the terminal points. Okay, so the rough graph comes out to look like this. It should be pulling up towards the different asymptotes. And then it'll continue on like this. And there we go. And then, of course, it would continue on up and off to the direction off of my graph. And for tangent, basically, as long as you list the intercept values and you indicate the 1 and the negative 1, you should be pretty good. Be a little too many points after that. Unless you're just graphing one period. If you're graphing one period, then I would like to see these points labeled on the graph. But right now, we're just graphing all of the periods, so we're not going to label all of those. So now let's go ahead and graph the function y equals cotangent t. So y equals cotangent of t. Well, the same thought process we're going to use, just like we did for tangent of x. First thing, we'll find the asymptotes, then we'll find the zeros, and then we'll find the ones. Well, the asymptotes, those come around when the denominator is equal to 0. And in our case for cotangent, the denominator is sine of x. So the question we're going to ask ourselves is when are the y values equal to 0? So when is sine of x equal to 0? Sine of x is equal to 0. Let me go ahead and pull up that unit circle that I just erased. Sine of x is equal to 0 at these values here, which is 0, pi, and 2 pi. So this time, those are going to be our asymptotes. So it's 0, pi, and a 2 pi. Alright, next thing we're going to ask ourselves, what are the zeros? Well, when is our function equal to 0? Our function is equal to 0 when cosine of x is 0. So the question is, when is cosine of x equal to 0? So cosine is equal to 0 here and here. And that point there will be pi over 2 and then 3 pi over 2. So there we have our zeros. So pi over 2 and 3 pi over 2. Lastly, let's find our ones. And that is, once again, where all of these values are equal to each other. Well, when are they equal to each other? We saw that earlier. They're equal to each other at all of the points, at all of the pi over 4s. That's when they're equal to each other. So let's go ahead and graph those in. So we know it was at pi over 4, and then here, here, and then here, as well as here and here. So we're actually going to end up seeing it's the exact flip reverse of what tangent looked like. Which makes sense, right? Because we're just flipping the fraction. Basically, it's like a mirror image of tangent of x. And once again, these are multiple periods of cotangent, excuse me. Now, let's take a look at graphing the function of y equals secant of x, which, if you recall, is the same as 1 over cosine of x. So, whenever we're graphing, what are the things you're going to look for when we're graphing the other four functions? It is asymptotes, zeros, and ones. Well, asymptotes. Once again, how do we find asymptotes? That's when our fraction is equal to 0. So in this case, asymptotes come from when cosine of x equals 0. And we found that previously up here on our unit circle. Cosine of x is equal to 0 at pi over 2 and 3 pi over 2. Next, we're going to find our zeros. Notice, is it ever possible for a fraction to equal 0? We have a 1 in the numerator. That will never equal 0, which means our fraction will never equal 0. So actually, we never have any zeros, so we never have intercepts. Interesting. The next thing we'll find out is any ones. Do we have any ones? Well, we'll have ones when cosine is equal to 1, right? Because in order for this fraction here to equal 1, the number on the bottom needs to be equal to 1. So when is cosine equal to 1 on our graph here? Well, cosine is equal to 1 here and here, positive or negative. So that's going to be at 0 or 2 pi and pi. Alright, so those are our ones for cosine. So we have at 0, the question is what kind of a 1 was it at 0? Because we're over here, that's going to be a positive 1 where we're looking at, remember, the xy coordinate system. So at 0, we're going to have a positive 1, and at 2 pi, we'll have a positive 1. And then at pi, we're back here in the negative quadrant, which means that we're going to have a negative 1. So at pi, we have a negative 1. Alright, and then for our graph, basically what happens is it goes up. We don't have any intercepts. Ooh, I graphed that side wrong. Sorry. That should be up at 2 pi. Okay. So 1, there we go. And as usual, remember, this is going to go off basically to infinity, because these are just repeating patterns, or repeating cycles of what we see in pi. Because it's just a unit circle. Alright, so you might be saying, well, gosh, how on earth does this come from cosine? Well, if you recall, what does cosine look like? Cosine goes from 0, 1, from 1, 0. It comes down, hits pi over 2, hits down here, pops up here, and then goes there. So that is what cosine looks like. And secant is the exact reverse of cosine. So pretty much it just pulls away from all the points on cosine, which is kind of interesting. So a lot of times, if you're not entirely certain how you should be graphing secant, sometimes if you just remember how to graph cosine, you can just reflect the sides off of cosine. Alright, last one here. Hopefully we're getting the hang of this. So now we have cosecant, which remember is equal to 1 over sine of x. First thing we're going to do is figure out our asymptotes. So our fraction is going to be undefined when sine is equal to 0. Well, the question is, when is sine of x equal to 0? Well, sine is equal to 0 at these points here, pi and 0, 2 pi. Let's go ahead and graph those. So it's 0 at pi, and 0, and 2 pi. Alright, next thing we're going to find are our zeros. So when would our function, or fraction, be equal to 0? Well, that can never be equal to 0, which means we won't have intercepts. Again, this has happened to us. Alright, so we don't have any zeros. The next thing to find on our list was the 1s, right? So when would our fraction equal 1? Well, it'll equal 1 whenever sign is also 1, positive or negative. So when is sign equal to 1? Sign is equal to 1 at these points here, because remember, sign are the y values. So it's equal to 1 at pi over 2 and 3 pi over 2. Alright, so let's go ahead and write that down. The question is it a positive or a negative 1 at pi over 2? Well, the answer comes to where it is in the xy plane. It's up in the top here, which means that it's going to be the positive 1 for pi over 2. Then for pi over 3, it's down in the bottom section, which means it is going to be a negative 1 for 3 pi over 2. Alright, let's go ahead and graph that. So negative 1 for 3 pi over 2, and then positive 1 for pi over 2. And then once again, very similar to secant, since there are no intercepts, we cannot graph downwards, which means we just must graph upwards. And what do I mean by downwards? Well, downwards, remember we have two options. Our graph needs to approach the asymptote at either going up towards infinity or down towards infinity. And we know it's not going down towards infinity because we have no intercepts. There are no zeros. So this option down here does not exist. That is not possible. Alright, so we'll go ahead and draw our cosecant. And once again, if we draw sine on this graph, we're going to notice that it's sort of the flipped version, which is kind of interesting. So this is sine, and notice our cosecant just sort of flips off, or reflects off, you could say, of our sine. Kind of interesting. Alrighty, moving on, transformations. So for tangent and cotangent, if we have y equals a tangent k of x, and y equals a cotangent k of x, they have period pi over k, which means if there is a number near x, you take that number and divide pi by it, and that is your new period. Okay. Ooh, one thing I think I forgot to mention. So a period. If you remember, for sine and cosine, secant and cosecant, they have a period of 2 pi. So a usual period that we might graph would be something like this, from 0 to 2 pi. And a usual period for cosecant would be something like that. Those would be considered one period for those two. For tangent, one period would usually be this one right here. Most people graph the one in the middle. You could graph the one here, but that's not as common. And then one period for cotangent would be usually the one right next to it over here, between 0 and pi. Alrighty, those were the periods for graphing, which pretty much we would use for transformations, because you're pretty much ever going to be asked to graph one period. Alright, so here we have our tangent and cotangent, which we did go over, with their period of pi divided by k if there happens to be a number inside times to your x value. Alright, so we're going to go ahead and graph one period of y equals 2 cotangent of x. Alright, so take a second and write down the important information for cotangent. So what do we need, or what do we know about cotangent? So the thing we need are the asymptotes, zeros, and the ones. So we need our asymptotes, shorthand for asymptotes, then we need our zeros, and then we need our ones. As usual, we always start with the parent function. So the asymptotes we found before, where we have at 0, it should be a 0, so at 0 and then at pi, those are our asymptotes. And remember, we're just graphing one period of cotangent. So we have 0 and pi. Next thing we had were the zeros, and the zeros were at just pi over 2. So we have pi over 2, 0. Next, we have the ones, and the ones were at pi over 4, positive 1, and then at 3 pi over 4, negative 1. Ooh, that 4 looked disgusting. Let me erase the 4. That was 3 pi over 4, negative 1. Okay, so 3 pi over 4, negative 1. And then at pi over 4, 1. Alright, and there we go. We have the basic parent function that you can use for this course. I don't know why my asymptote disappeared. There we go. Okay, so that's the basic parent function for cotangent of x. Now let's take a look at the transformation. So what is different about this function? Well, we have that 2 being multiplied outside of cotangent, which basically means we're just going to be having an amplitude of 2. So amplitude of 2 which means we're going to multiply our y's by 2. So our y values, let me go ahead and highlight those. We have our y value of 1, 0, and negative 1. The other values will remain untouched, which means that our asymptotes stay in the same place. Nothing happening on those. It's just our y values. So let's go ahead and change those. So it's going to be pi over 4 positive 2 now, because we multiplied the y's by 2. And then, well, when we multiply 0 by 2, nothing happens, so we're going to stay there. And then, over here at 3 pi over 4, the negative 1 gets multiplied by 2 and becomes a negative 2. And there we have our new sort of stretched out version of cotangent. Okay, so now let's take a look at example 6. Take a moment, pause the video, and try graph the parent function of cotangent again. Check in with me in a sec. Alright, so I went ahead and graphed the parent function of cotangent. So as usual, we have the asymptotes at 0 and pi, and then we have our intercept, or a 0, at pi over 2, and our 1's at pi over 4 and 3 pi over 4. So now let's take a look at our function. What is different? Well, the only different thing here is we have that negative, which means it's going to be a reflection. So we're going to have a reflection about what? Well, that's going to be a reflection about the x-axis, which means we're going to multiply the y values by negative 1. Once again, these are all based on transformations that you learned in 135, and if you need a refresher on those, please let me know. Alright, so multiplying the y values by negative 1. Let's take a look at the y values. We have 1, 0, and negative 1. Well, nothing happens to our asymptotes, so let me go ahead and draw those in again. Okay, nothing happened to our asymptotes. The only thing that happens is our y values multiplied by negative 1. So that becomes down here. So pi over 4, negative 1. Nothing happens to our pi over 2, 0. And then we go up here to the 3 pi over 4, positive 1. And there we have our cotangent with the reflection about the x-axis. Alright, now let's take a look at example 7, graphing one period of y equals 2 tangent of x minus pi. Ooh, so we're using a new function now. We're talking about tangent, which means we're going to go ahead and graph the parent function first. So take a sec to go ahead and graph the parent function of tangent. Really quickly, I'm going to write out the information that we need for tangent. So the things we know the asymptote are going to be a negative pi over 2 and pi over 2. Once again, you can graph different periods, but the one I usually graph is between negative pi over 2 and pi over 2. Then the zeros that we have are at 0, 0. And what do we know? Well, the ones we had at negative pi over 4, negative 1, and pi over 4, 1. Now remember, there are more 1s and 0s. Because remember, it's sort of an infinite graphing of tangent of x. But usually we just look at one of the periods, which just means one circle around the unit circle. Sorry, scratch that. For tangent and cotangent, it's just pi. It's not the whole unit circle. So just one period of length pi. Alrighty, I'm going to go ahead and pause the video. I'll graph tangent and check in with me in a second. Alright, so we have the parent function of tangent down. Now the next thing we should do is figure out what different transformations there are going on here. Well, I notice inside of x, we have x minus pi. So that is going to be a phase shift. And the next thing I notice is we have the 2 outside here of tangent. So that's going to be an amplitude of 2. Alright, now let's do the amplitude and then the phase shift last. So we have an amplitude of 2. One thing to note, especially for your exams, write out the different transformations. These are something I will be grading for. So if you just drew the graph, that would not earn the full points. Please write out the transformations as well as draw the graph and label the points. Alright, so we have an amplitude of 2. What does that mean? Well, that means you're going to multiply the y values by a 2. Alrighty, so our y value is by 2. Alrighty, go ahead and do that. Check in with me in a second. Alright, so I went ahead and I graphed in the new amplitude of 2. So it has definitely stretched our graph. But if you'll notice, the asymptotes have stayed in the same place as well as our 0, 0. Those have not changed. So the next thing we have is the phase shift. Minus 2. So let's go ahead and write that down. We have a phase shift of what? Well, as usual, the x values are weird. Even though it's a minus, we're going to be moving to the right. So it's a phase shift of pi to the right. Okay. Once again, we had a phase shift of pi to the right because we're minusing the pi. Well, what does that mean? That means we're going to be adding pi to the pi values. I just call them pi values for shorthand. Alright, so what are the pi values? Well, the pi values, let me go ahead and move up here. This time, they include the asymptotes. So we're going to be shifting our asymptote values as well as these pi values here. So we're going to be adding pi to those values. Let me go ahead and do that on the side here. So for our asymptotes, we're going to be adding pi to negative pi over 2, as well as adding pi to pi over 2. And that's going to be moving our asymptotes. Then our 0 is going to be moving. Well, the 0 is not too bad. 0 plus pi. Let me go ahead and write this down. Our points. The 0 is that's going to just be moved to pi 0. Not too bad. Then we have the negative pi over 4. So let's go ahead and we know we're going to have to write that down. So negative pi over 4 plus pi. What's that going to give us? And then we have the positive pi over 4 plus pi equals. Alright, I'm going to go ahead and pause the video and calculate these values. And then check your answers with me in a sec. Alright, so we have our new values. So our 2 new asymptotes are at pi over 2 and 3 pi over 2. We'll go ahead and draw those in. We've shifted over a total amount of pi. Pi over 2 and then 3 pi over 2. And then, let's see, so we had our point pi 0. That one was pretty easy to find because we just added pi to 0. Next, we had the point, so negative pi over 4 got shifted over. So that's going to be negative 3 pi over 4, negative 2. So that'll be down here. Negative 3 pi over 4, negative 2. And then lastly, our other point is 5 pi over 4, positive 2. 5 pi over 4, positive 2. So once again, all the work here I'm showing is work that I will be looking for on your exams. Alrighty, And there we go. We are finished with the transformation of our lovely function y equals 2 tangent of x minus pi. Now here we go, example 8. So as usual, I'm going to ask that you graph the parent function. So what is the parent function here? Well, we're looking at cotangent. So we have y equals cotangent of t. And what do we know about cotangent? Well, the asymptotes are x equals 0 and x equals pi, or just 0 and pi. We'll go ahead and just write 0 and pi. Let's go ahead and graph those in. So once again, there are, remember, different periods for cotangent, but this is the general one that we're going to use. It's just the general one that is shown for transformations. Next, we have the zeros. And the zeros are just pi over 2. So pi over 2, 0. And now, lastly, we need the ones. And the ones are pi over 4, 1. And 3 pi over 4, negative 1. So pi over 4, 1. And 3 pi over 4, negative 1. And there we go, drawing in the parent function of cotangent, one period of cotangent. Now let's take a look at what transformations we have for this graph. Well, you know what's weird is usually we're given the concept, if you notice back in the beginning when we talk about tangent and cotangent. Let me go ahead and pull it up. Where are you? There we go. So, we're told that we have some number a times cotangent times x. And then we'll have the period of the value times our x. But if you'll notice what we have down here, we don't have something times our x. We have x divided by 2. So we can't have that. We need to change this into the form of y equals cotangent of some number times our x value, and then we can do plus or minus the other number. Okay, we need to have x completely by itself. It cannot be a fraction. And at the moment, x is a fraction. So we have to change that. How will we change it? Well, the method we're going to use is factoring. So we're going to factor out a number that can make our x value by itself. So usually you just factor out the number that is being multiplied to x. And what number is that? Well, that's a half. So let's rewrite this. So we have y equals cotangent of x. That is x times a half plus. Now, because this is a binomial, we need to factor out the same number from both the x divided by 2 and the pi divided by 8. So 8 is 2 times 4. So this will be a half times pi over 4. So now we can factor out that half because both of the terms have it. So factoring that out, we have that y equals cotangent of half x plus pi over 4. And there we go. We have written our function correctly in order to find any phase shift or any period change. So we have our new function. Let me go ahead and write it down here. Well, it's not a new function. It's rewritten in a way that's easier to find our transformations. So once again, what did I do? I got x to be by itself. It's no longer in a fraction form. And that's what you want to do in order to read off your period. So let me go ahead and find that. Your period value, which is going to be the half, and then any phase shift, which will be whatever's plus or minus to the x. As usual, we'll leave the phase shift for the end. So what is our period? Well, for cotangent, what is the usual period for cotangent? The usual period is pi. Okay, and then we're going to go ahead and divide that by a half, which is the value we have out here. So we'll go ahead and divide that by half, and we end up with our new period of 2 pi. So what are we going to do with that 2 pi? Well, that is going to be the width or the length of our new period. And in order to find that for all our other values, we're going to go ahead and multiply all our values by 2. Okay, so let's see. Once again, where did I get 2 from? Because we ended up multiplying our period by 2. So let's see, all of the values we have. Well, our asymptotes are some of the pi values we have. And those we have at 0, and at pi. Let's go ahead and multiply those. So here we go. Let me write out the asymptotes. I'm going to multiply those by 0. Sorry, we're going to multiply those by 2 pi. So we have asymptote 0 and pi. Multiplying those by 2 for a new phase, or a new period, sorry. 0 and 2 pi. Okay, so there we go. It goes from 0 to 2 pi. Those are our asymptotes. Let's go ahead and graph those in. Okay, so we've done our asymptotes. Now we have 3 other things to do, the zeros and the ones. Now our 0 is at the point pi over 2. Multiplying that by 2, the 2's will cancel, and we'll just be left with pi. So we have our new 0 at pi. So we have pi 0, and then let's do our ones. Our ones we have pi over 4 and 3 pi over 4. So pi over 4 and 3 pi over 4. Multiplying those by 2. Let's see, that simplifies, and we get pi over 2. And then the other one also simplifies, and we get 3 pi over 2. Those are our new ones. The value of the 1, though, has not changed. So the pi over 2 is still at the positive 1. And the 3 pi over 2 is at the negative 1. Alright, so there we go. We have stretched it out because of our new period. Oh, let me erase that last section. So stretched out with our new period, and we only have one other thing to do for this, and then we're done. Alright, let's see. There we go. And one thing to note real quick, when you're graphing this, make sure that your graphs are slowly approaching your asymptote. They should not sort of bounce back up on a graph. That is something that you would probably lose some points for on an exam. So make sure that you are doing your best to copy what the graph is supposed to look like. And always include your arrowheads as well. Okay. Arrowheads, awesome. Next thing we did, okay, so we did the period. Now let's do the phase shift. Oh, I just realized I forgot to label this. So we have period of pi, 2 pi. There we go. Okay, so make sure to always label your transformations. The next thing we have is a phase shift of what? Of pi over 4, and it's a plus, which means we're going to actually be going to the left. Pi over 4 to the left. So once again, this is going to affect our pi values. So what are we going to do? Well, we're going to be subtracting pi over 4 from all of our values. Let me go ahead and copy them all down again. So we have our asymptote, which we now have at 0 and 2 pi. Then we have our zeros, which we now have at pi, just 1, 0. And then we have our ones, which are at pi over 4 and... Ooh, sorry, no, that's our old one. Pi over 2 and 3 pi over 2. Remember, we're building off of these. So we have our zeros, our ones, and then our asymptotes. And we're going to be subtracting pi over 4 from all of them. Okay, so I'm going to go ahead and let you do that calculation by yourself. And I'll graph it and check your work with mine. Alrighty, so we have the finished graph of a transformed version of cotangent. Alrighty, next problem. So now we're looking at secant and cosecant. And remember, these are the reverses of sine and cosine. So if we have y equals a times secant k of x, and y equals a times cosecant k of x, they have a period of 2 pi divided by k. Okay, so once again, secant and cosecant have the same period length as sine and cosine. It's tangent and cotangent that only have a period length of pi. Alright, so what do we have here? Example 9, graph one period of y equals secant 2 times x minus pi over 2. Alrighty, as usual, what we're going to do is we're going to start with the parent graph. And what is the parent graph? It is y equals secant t, or secant x. So for the one period, this is going to be the normal parent graph that I'll be looking for. So we'll use the asymptotes of, let's see, pi over 2 and 3 pi over 2. Once again, there are many, many different periods of all of these trigonometric functions, but these are the main ones that we usually use. So here we go. These are the ones that I'll expect you to graph. Once again, if you recall, there is another asymptote on negative pi over 2, but we are not going to be using that because we're only using one period. So we'll go ahead and erase that. Next, what do we know? Well, we don't have any zeros, so no zeros. But we do have some ones. And we have ones at pi negative 1, 0, 1, and 2 pi 1. So let's go ahead and plot those in. So at 0, 1, we have a 0, or sorry, a 1. Pi negative 1, and 2 pi 1. And now, so usually, if you recall, actually let me go ahead and graph in that other asymptote that we were talking about, that we're not going to be usually using for a parent function. So normally, you'll recall that secant looks something like this. But because we're only using one period of it, I'm going to go ahead and erase the values we don't need. So you just need to show this for one period. Those are the values we need. I'm going to go ahead and fix that other side. Okay, so it's sort of a weird three-piece looking graph. Alrighty, and these are just the points I want to see. Okay, those three are the ones that matter. Alrighty, so there we go, the parent function. Next we need to decide what else is happening with our function. Well, it looks like we have a period change of 2 and a phase shift of negative pi over 2. And phase shifts are last, so let's go ahead and do the period change. So the period change, what happens? We have a period change of 2. So our usual period is 2 pi. We're going to divide that by our new period, 2. Actually, we change that to a color of yellow. Those cancel, and we have a new period of pi. So what are we going to do? We're going to multiply all of our pi values by 2 for a new period change. Alright, let's see. What are our pi values? We have 0, our asymptote. Let me go ahead and highlight the whole thing. Then we have pi, and then our other asymptote, and lastly 2 pi. So these are all the values that will be changed by the new period. So let's go ahead and work with those. Alright, so separating them out, we have our, I don't know why I said zeros. Those are our 1 values, our 1s, and then our asymptotes. Sorry if I called them zeros, those are not zeros, those are 1s. So 1 values are at 0, pi, and 2 pi. And then our asymptotes are at pi over 2 and 3 pi over 2. And now we're going to multiply all of these by a half. Or we could say divide them by 1. And what do we get when we do that? Well, 0 times a half is 0. Pi times a half is pi over 2. 2 times a half is just going to be pi. Pi over 2 times a half is pi over 4. And 3 pi over 2 is 3 pi over 4. Alrighty, so we have our new values. Go ahead, plot those, and check in with me in a second. Okay, so hopefully your graph looks like mine. We went ahead and plotted all the points and used all the asymptotes. Now the last thing after a period change is we are looking at the phase shift. The phase shift is minusing pi over 2, so as usual, the weird thing with x's, we'll be adding pi over 2. So we have a phase shift. Phase shift, which direction? Phase shift, I said adding, right? Right. How much? Pi over 2. Let me just check that I did that right. Yep. So we're going to be adding pi over 2 to all of our values. Let me go ahead and write those down again. So we had our 1s, which are new ones, are 0, pi over 2, and pi. And then our asymptotes are pi over 4 and 3 pi over 4. And what are we doing with all of these? We are adding pi over 2 to all of them, because we're phase shifting. Okay, so adding pi over 2 to all of them. Let's see, this doesn't need a common denominator, that's just pi over 2. That's going to be pi. That'll be 3 pi over 2. Once again, you could think of it 2 pi over 2. Here we need to create a same denominator, so that'll be 2 pi over 4. Same thing with the bottom one, 2 pi over 4. Then we'll be left with 3 pi over 4 and 5 pi over 4. Okay, so our new asymptotes. We have 3 pi over 4 and 5 pi over 4. Okay, so we have the asymptotes in. Now let's go ahead and draw the other values. So we have our ones at pi over 2, 1. And that goes up. Then we have the other one at pi negative 1. I just realized I graphed that one asymptote wrong. Okay, that asymptote is supposed to be at 5 pi over 4, which is right here. Sorry about that. Alrighty, so we have our 0. Let's see, and how did I know I graphed it wrong? Well, because pretty much our graph should always be perfectly centered between our asymptotes. So that let me know that I had graphed it a little off. Okay, so we have our negative pi, sorry, not our negative pi, positive pi with the negative 1. And then lastly, we have our 3 pi over 2, positive 1. And there we go. We finished our graph. Alright, not too bad. Well, hopefully it's not too bad. Once again, if you have any questions, please feel free to set up an office hour with me, and I'll be glad to go over things with you. Now here we have graphing one period of y equals half cosecant 2x minus pi over 2. So first off, before we start this, what is our parent graph? Well, our parent graph is cosecant. So I'll write that down. So y equals cosecant of x or t. So that's our parent graph. What else do we see happening with our function? Well, I see that we're going to be having a stretch, or an amplitude change, you could call it. And then, ooh, notice there's a 2 by an x. So we need to get x by itself. So I'll have to be factoring something out in the end. So I see that on the horizon. So let's go ahead and graph one period of y equals cosecant of x. I'll write down the main values for you, and then I'll have you graph that by yourself and check in with me in a second. So what are the main values? Well, we have our asymptotes, which are at 0, pi, and 2 pi. Then we have no zeros. And what about our ones? Well, the ones we have are pi over 2, 1, and 3 pi over 2, negative 1. And once again, there are different periods you could do, but this is the usual period that most of the time you would use for graphing transformations. It's the main period that people look at. Alrighty, go ahead, graph this and check in with me in a second. Alright, so I've done our parent graph. We have the 3 asymptotes and the 2 main points, which is different from secant. Secant, you have 3 points and 2 asymptotes. Alright, so now let's take a look. Before we can do anything, I need to rewrite this in the proper order, which means I need to factor out something from inside here. How would we get x by itself? Wait, let me rewrite that. So to get x by itself, we know it needs to be 2 times x minus, I need to take out the same factor from both of these guys. So how can I rewrite pi over 2 as 2 times something? Well, that's the same as 2 times pi over 4, right? Because if the 2 and the 4 canceled, we'd be left with the original pi over 2. Okay, sweet. So I've been able to rewrite this with both of them having the factor of 2, which means I now can factor out that 2. And I'll be left with y equals 1/2 cosecant of 2 times x minus pi over 4. Awesome. So now I can see the other items happening with my transformations. So I still have that amplitude of a half happening, and then I see that I have my period change of 2 and my phase shift of, let's change the color, phase shift of negative pi over 4. Phase shifts are last, period change is first, so we'll go ahead with the period change, then we'll work on the amplitude, and lastly we'll work with the phase shift. Okay, so what is our period change? Our period change is, at the moment we have a 2, so to find out our new period, what's the normal period of cosecant? Yeah, it's 2 pi. So the normal period is 2 pi, then we're dividing by 2, and the new period is pi. That means we're going to divide all of our pi values by 2 to find the new placements for everything. So what are our pi values? Our pi values are as follows. Asymptote, 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 these guys. Alright, let's go ahead and multiply all those by a 2, or divide by 2 to find the new ones. So let's see, here's, let's do my 1s. So our 1s, we have pi over 2 and 3 pi over 2. And then my asymptotes, we have 0, pi, and 2 pi. Okay, we're multiplying all these by a half, which again is the same thing as dividing by 2. Alright, so then we get pi over 4, 3 pi over 4, 0, pi over 2, and pi. Alright, let's go ahead and plot those points. I'll pause the video, plot them myself, and then you'll compare your answers with me. Alright, so we've finished with our period change. Next thing we're going to go ahead and do is the amplitude. So it's a half. So we have an amplitude of half. Which means we're going to multiply the y's by a half. What are my y values? Well, we don't have too many y values. We've only got 2. And those y values are, let's see. Oops, wrong one. Pi and, I said pi, 1 and negative 1. So my y values, we have 1 and negative 1, multiplying those by a half. We'll get our new values of half and negative half. Ooh, getting smaller and smaller by the minute. Okay, so let's go ahead and graph those values. Once again, the pi values will stay in the same places. The only thing that changes is going to be our y values. So I'm filling in my asymptotes. And my pi values are still pi over 4 and 3 pi over 4, except now we go to half and negative half. And zoop. And then we go ahead and label 3 pi over 4, negative half, pi over 4, 1 half. Or sorry, half. Awesome. Ooh, we're almost done. Okay. That was amplitude. We did the period. Now, next thing we gotta do is the phase shift, which I have written in green. It is a negative pi over 4, so with the x's, once again, opposite direction. So we have phase shift. Please let me know the direction, right or left. Phase shift, it was a minus pi over 4, so we're going to phase shift right. Right pi over 4. And that means we're going to go ahead and add pi over 4 to all of our pi values. So what are our pi values? Where we have our 1s, which are pi over 4, and 3 pi over 4. Let me go ahead and highlight those so you remember where I got them from. Pi over 4 and 3 pi over 4. Then our asymptotes are going to be at 0, pi over 2, and pi. So my asymptotes. We have 0, pi over 2, and pi. Now phase shifting, we're going to move them to the right, so we're going to be adding pi over 4 to all of these. Okay. Go ahead and work on that and check in with me in a second. Okay, so now I have all of my new pi values. Once again, we're just moving the pi values, not the y values. So my new 1s are going to be at pi over 2, half. Remember, we still have that same y value. So it's pi over 2 half. And then at pi, oh, just pi. Pi negative half. Alright, so we did the ones. Now let's go ahead and do the asymptotes. So we have 1 at pi over 4. And then at 3 pi over 4. And at 5 pi over 4. So you don't need to label the asymptotes as long as you wrote them down somewhere on your work. So if you didn't write down your asymptotes somewhere like this and label them, once again, if you do not label them up here somewhere and show them, then please label them on your graph. I will be looking for them either on your graph or labeled somewhere elsewhere. But always label the points on your graph. Okay, then the only thing we have to do now is draw our graph in. The final huzzah! Don't you feel proud of yourself? Hopefully you feel proud of yourself. You're working hard. Alrighty, and there we go. That is the graphing of, what is it? Y equals half cosecant 2x minus pi over 2. So once again, what are the main things? If you do not see x by itself, you are going to have to factor something out. Just a heads up. Alrighty, so this is the practice problem. Once again, go ahead and work on that. You don't get any points or anything for the practice problems. It's just for your own side work, because this is the summer course. But I'll go ahead and upload the answers to those on La Lima. Other than that, that is it for 5.4. Please email me if you have any questions or would like to set up an office hour.